Hey physics, Caden here. Boom! A collision. Whether it be a car crash or a bowling ball, things collide with each other all the time. But what happens during these collisions? And why do the objects in said collisions react the way that they do? Whoa! To understand a collision, we first need to understand momentum.
What's momentum, Mr. Erickson?
Well, I'm glad you asked, Random Voice. Momentum is a relationship between the mass and the velocity, being the speed and direction of an object. Only when an object is in motion does it have momentum. An object at rest always has zero momentum because its velocity is zero. Momentum is represented by the variable p. And we can find momentum by using the formula p equals mass times velocity. Any object in motion can have momentum, like this tennis ball. Mr. Hand, if you don't mind. Thank you, Mr. Hand. You can go now. Right now, because the ball is at rest, it has no momentum. But when I throw the ball, now because the ball is in motion, it has momentum. Let's go inside, it's freezing out here. Now, to find the momentum of the tennis ball, we need to know two things: the mass of the tennis ball and its velocity. The tennis ball has a mass of 58.5 grams, or 0.0585 kilograms. Generally speaking, I threw the tennis ball at about 10 meters per second. Using our formula and plugging in for our variables, we can determine that the tennis ball had a momentum of 0.585 units of momentum. Now, let's get serious. Whew! That right there was a 2005 Honda Civic, barreling down the highway at a whopping 25 miles per hour. Although a much larger amount, my 2005 Honda Civic, or Meredith as I call her, also has momentum. Remember the tennis ball? Well, using the same strategy, we can calculate Meredith's momentum. According to Google, since I don't have a scale large enough, Meredith has a mass of 1,261.9 kilograms. And was traveling at a velocity of 25 miles per hour, or 11.18 meters per second. Using our formula and plugging in for our variables, we can determine that Meredith had a momentum of 14,108.04 units of momentum. Holy smokes.
When do we get to the collisions?
Right now, Sonny, so shut it. There are two types of collisions: elastic collisions and inelastic collisions. An elastic collision is when two objects collide and the objects remain separate with separate velocities after the collision, and kinetic energy is conserved. Ooh, that's gotta hurt. Here we can see that after the collision, there are still two objects. Each object has its own velocity, and the total kinetic energy is conserved. An inelastic collision is when objects connect together after a collision and share a common velocity. Kinetic energy is not conserved in an inelastic collision. Imagine two train cars linking together. One train car collides with the second train car, but then both cars move together as a single object with the same velocity after the collision.
Come on, let's get to the crashing already.
Who let him in here? Get out of here. Ugh. Finally, we need to discuss the law of conservation of momentum. The law of conservation of momentum states that the total momentum of objects before a collision must equal the total momentum of objects after a collision. Pretty simple. Now for the good stuff. Ooh, that was a rough one. However, here we can see the perfect example of the law of conservation of momentum. Each car had its own momentum before the collision, And after the collision, the combined momentum of both the cars was equal to the combined momentum of the cars before the collision, which we can see by doing a little bit of calculating. Ta-da! Bam! That was momentum. So the next time you see two things colliding, you can tell everyone what you know about momentum and how it works. Thanks for watching. The mass of the tennis ball and its velocity. Dog. Variables, we can determine that the tennis ball okay. Woo! That right there was a 2005 Honda Civic. Although a much larger amount. Sorry, I messed it up already. Let's do it. Bam! That was momentum. So if the next time you see two things